Hello, Matthews Gatos here. In this video, we're going to look at the general term of a binomial. Let's get started. So in the first one here, I want to find the third term. Now I could expand this, count out what my third term is, but what I'm going to do instead is use the general term formula. So this one right here. So to do this, I just have to figure out what all my parameters are. So this is n. This is x, my first term. This is y, my second term. I just have to figure out what k is. So if I want the third term, does that mean k is 3? Well, if I put in a 3 here, I'll have 3 plus 1, which would be the fourth term. So k is not 3. In fact, k is always 1 less than the term number, because if I put a k value of 2 in there, 2 plus 1 is the third term. So I know that k is equal to 2. So let's apply it into our formula. So t sub k plus 1 equals nck multiplied by x to the n minus k multiplied by y to the k value of 2. So that means I have the third term, 6c2, is 5m squared to the 4 multiplied by 2 squared. Okay, let's separate out all the numbers. So 6c2 times 5 exponent 4 times m to the 2 times 4 is 8 times 2 squared. So if I look at just the numeric values, I can multiply those together. And I end up getting that my third term is 37,500 m exponent 8. That would be your third term. Okay, let's try another one. In this one here, I have the expansion of this binomial, and when I expand it, one of the terms has an x exponent 5. I want to figure out which term it is. So again, similar thing. I don't know what my general term is, but I'm going to substitute this in for my general term. This is my n value, this is my x first term, and this is my y second term. So let's plug that into our formula, see what we get. So tk plus 1, which would be the term that contains the x exponent 5, is nck, we don't know k, first term to the n minus k, second term, negative 2x to the negative 1 to the k. So let's tidy this up again, and we're going to separate out our numbers again. So this would be x to the 3 times 7, 3 times negative k. So that would be 21 minus 3k. And then negative 2 to the k, and x to the negative 1 times k. Now, what I'm going to do is focus just on my numbers, because I want to figure out what my k value is. So the numbers are not really helping me right now. I'm going to focus in on my variables. So I have x to the 5 equals. Now I'm going to combine those together using product law, which says keep the base the same, add the exponents. So tidying that up, I have 21 minus 4k. So to solve for this now, what I'm going to do is do what many wedding DJs do, and I'm going to drop the base and make the exponents equal to each other. So then I just have to solve this linear equation. So I will subtract 21 from both sides, and I get negative 16 equals negative 4k. Divide both sides by negative 4, and I get that k equals 4. So the question asked us for what term contains x exponent 5. So does that mean if k equals 4, it is the fourth term? Well, that would not be correct. If k equals 4, remember the term is 4 plus 1. It's actually the fifth term. So the fifth term in that expansion contains the term, or the exponent x to the exponent of 5. The term has x exponent 5. Let's try a little bit of a twist for this one here. So in the expansion of x minus 2 over x to the 8, what is the constant term? So first thing we need to know is, what does constant term mean? Constant term is something that never changes. It's the lonely number. It has no variable. So if it has no variable, I could say it's an x to the exponent of 0. So let's plug in everything we know again. So this is my first term x, this is my second term y, that is my n value. So again, I don't know k. So I'm going to use a similar approach to solve for what k is. Now I know that my general term has an x exponent 0 in it. So let's plug in everything we do know. So 8ck times my first term to the n minus k, second term to the k. So I have x to the exponent of 0 equals, let's again separate anything out with a number. So this is 8 minus k, and then negative 2 to the k, and x to the negative k. So to figure out what k is, again, we want to focus on just the variables. So I'll just get rid of anything that has just a number in it. So I have x exponent 0 equals x to the 8 minus k times x to the negative k. I'm going to keep my base the same, and I'm going to add my exponents. So this is x to the 0 equals x to the 8 minus 2k. So again, we're going to do our wedding DJ move, drop the base, and then solve for k. So I have 0 equals 8 minus 2k, add 2k to both sides, and divide both sides by 2, and I get k is 4. Now that I know what k is for, I can go back up here and figure out what the actual constant term is. Okay, so my constant term is going to be 8c4 x to the 8 minus 4 times negative 2x to the negative 1 to the 4. Let's tidy this up. So 8c4 times x to the 8 minus 4 is 4. Negative 2 to the 4 times x to the negative 4. Now you can see here that my variables get rid of each other, because if I keep the base the same and add the exponents, 4 plus negative 4 is 0. So that means that my constant term is 8c4 times negative 2 to the 4. So I just plug that into my calculator and find that my constant term, the one without a variable, is 1,120 is the constant term. I also know it's going to happen in the fifth term. So the fifth term will be my constant term when I expand it, and it will have a value of 1,120. Okay, let's look at another one. Similar idea, but we're going to be working backwards to find out what y is. So one term in the expansion of this is my first term, my second term, my n value, and this is tk plus 1. So again, anytime you're trying to figure out a term or part of a term, you're always solving for k. So let's plug this into our formula. So this is tk plus 1, and that's going to be nck, first term x to the n minus k, second term a to the just k value. Okay, now value of a tells us that it is a number. So let's see what we can do with this. To solve for what a is, I'm going to divide my numbers. So I know that, no, I'm not going to divide my numbers. I take that back. This is what I'm going to do. I'm going to focus on my x values. So in these x values, if you have x to the exponent of 8 has to equal to x to the 11 minus k, I know that 8 has to equal 11 minus k, which means that k has to equal 3, because 11 take away 3 is 8. Okay, I know k is 3. Let's go back up into this. So I have negative 4,555 x exponent 8 equals 11c3 times x to the 11 minus k is 8 times a to the k, which is 3. Okay, now I can divide numbers. I couldn't divide before because I had a k value. So I see with the equation, I have x to the 8 on both sides. I can cancel those out. So I'm left with negative 4,455 equals 11c3 times a cubed. Now I can divide. So I'll divide both sides by 11c3. So I'll just pop that into my calculator, and I end up getting negative 27 equals a cubed. So to solve for that, I would just take the cube root of both sides, and then I see that a is, the cube root of negative 27 is negative 3. So the value of a is negative 3. Okay, in our last example here, we have similar idea again. We're finding the value of p. These questions here are classic diploma questions, so really important that we go over these. So in this one here, this is again my general term. This is my first term. This is my second term. This is my n value. So let's plug everything into our equation. So we have 24,192 m exponent 5 over 25 equals nck x, which is 2m, to the n minus k, y, which is p to the k value. Okay, so we want to kind of simplify this out, see what we end up getting. So I'm going to separate out my numbers so I can focus on what my k value is. So 7ck, 2 to the 7 minus k, m to the 7 minus k, and then p to the k. Now p is a number, that's why it's asking for a value. What I'm going to focus on here is my m value. See how I have m to the 5 and m to the 7 minus k? Well, I know that 5 and 7 minus k, the exponents have to be equal if it's an equation. So I know that 7 minus 2 is 5, so now I know my k value is 2. So I'm going to plug in my k value now. So 24192 m exponent 5 all over 25 equals 7c2. 2 to the 7 minus 2 is 5. M to the 7 minus 2 is 5. P to the 2. So again, I see m exponent 5 on both sides. So now I can just focus in on my numbers. So 24,192 over 25 equals 7c2 times 2 exponent 5 times p squared. So I am going to divide both sides by 7c2, 2 exponent 5. That's just a number. So divide both sides by 7c2, 2 exponent 5. So that is gone, and I'm going to be left with p squared. So I put this into my calculator to figure out what my numerical value is. So I plug it into my calculator like that, and I get 36 over 25. So 36 over 25. So now I just have to take the square root of both sides to figure out what p is. Now remember in math, when you take the square root of something, the answer could be positive and negative. So square root of 36 is 6, square root of 25 is 5. So that means p is equal to plus or minus, I believe they want it to the nearest tenth, yes. 6 divided by 5 is 1.2. So two different answers, because a positive squared is a positive, and a negative squared is also a positive. So this is some good examples of binomials, but I just want to talk about my friend parrot here. What do you call a parrot that hasn't eaten breakfast? Well, it's not a binomial, it is a polynomial. Get it? See, you thought I wouldn't have a joke, but there it is. So I hope that this video helped you guys, and I look forward to seeing you for the next one.